Hello, thank you. Again, my name is Greg McConnell. I'm a specialist SA for security. And today I'm going to be talking to you about the evolution that many companies go through around identity and access management. We'll discuss the root user, IAM users, groups, and roles, and then we'll spend the bulk of the time looking at identity federation. The reason why I'm positioning this as a talk on the evolution is that identity federation should be the ultimate step you take as you use identity and access management on AWS. It's not the only solution for secure identity and access management, but as you scale your use of AWS, it will provide the most benefit and options. I'll be spending a short time in the slides, but most of this webinar will cover 2 identity federation demos. This is just to give you an idea of what's out there. There are many ways to do identity federation, and I'm not advocating any one particular method. I just want to hopefully show you that identity federation is a great solution in just about every case, and hopefully this will lead some of you who are not currently doing identity federation to consider it. This is a level 300 webinar. I'm going to assume you're comfortable with a few concepts: IAM, roles, policies, the security token service, and then long-term access keys and temporary security credentials. But we will have experts available throughout the webinar that can answer any questions you have through chat. We will also go through a few questions live at the end. All right, let's start looking at the evolution. We start with the root user, represented by a paper airplane. Next, we move on to users, groups, and roles, represented by a helicopter. And finally, you have identity federation and a rocket to represent that. When you first open a new AWS account, all you have is the root user. The process is different when you're using organizations, since that will create a role for you. But in general, this is how you start. I'm going to use a simple analogy as we go through these different steps in the evolution. The analogy will involve a business, some buildings, and access to those buildings. The scenario is that you start a new company and lease a building and need to give your 5 employees access to the building. And so that we are clear, the building represents an AWS account, the key represents a username password or an IAM access key. The root user is similar to the idea where you have one key that opens all the doors and you copy that key and hand it to all your employees. This works early on, but there are some problems. Although you can audit that someone entered the building, you can't attribute it to one individual. There's no accountability. You can't restrict access to certain parts of the building, etc. Also, as the company grows, you lose track of how many people have a copy of the key. Also, there's a good chance that people who have left the company still have their copy. The point here is don't use the root user. Lock it down with MFA, either hardware or virtual. Consider using quorum access for AWS accounts with sensitive info, where you keep the MFA token separate from the root user password. And definitely remove the IAM access key from the root user. There are still some situations where the root user is needed, so you want to make sure you can get access to the root user, but you don't want to make it easy to use or a normal activity. Moving on, users, groups, and roles. This is usually the next step in the evolution. You create IAM users to grant access to AWS, you use groups to bundle up the users, and you use roles in a number of different ways, including IAM roles for EC2, cross-account roles, switch role, etc. Okay, continuing on with the analogy. So next you hire a security company to implement a badge system in the building. They maintain a database of your employees that you control and hand out badges. The provisioning and deprovisioning of employees in the badge system is separate from your corporate directory. So now you have to keep track of both systems. You can properly audit building access, since you can view activity by individual employee and give different levels of access into the building based on the employee job role. This is an improvement over that one key you used to copy and hand out, but it's a hassle to deal with this separate user database for the badges. And there's the concern that once someone leaves the company or changes job function, that their access is not properly modified. You already have a process for provisioning and deprovisioning employees in your internal company database, but you may not have extended this completely to the building badge user database. Let's make this a little more complicated. The company has expanded and added a number of buildings. You have research and development buildings, manufacturing, etc. And employees need to access various buildings based on their job role. So we work with the security company and create user databases at each building and get a badge for each building. So now we have to maintain a number of different user databases in addition to our own internal employee database. We have to worry about the entitlements or rights set up in each building, and our employees have to carry a badge for each building they need access to. This clearly doesn't scale. And to pull out of the analogy, what I'm talking about here is maintaining separate IAM users in each of your AWS accounts. Later, we work out a system with a security company at all the buildings to let us use the employee database at some central building to allow access to all the other buildings. Okay, so stepping out of the analogy again, what I just described is often called a landing account or jump account. In this situation, which is fairly common, you use one central AWS account to house all the IAM users. Then the users use switch role to assume roles in all the other AWS accounts by jumping from that landing account to the other accounts. I would call this Federation Light. It's pretty close, but doesn't quite get you all the way. You still maintain two user databases, the internal corporate directory and AWS IAM users in that central account. Your users need to know ahead of time all the various roles they can assume in all the other accounts. Still, this is clearly better than maintaining IAM users in every AWS account you own. All right, on to the last stage in the evolution, identity federation. Jumping back into the analogy, soon you have about 20 buildings and 1,000 employees. The complexity and cost of maintaining a separate user database, that landing account setup, at the security company is no longer worth it. You work with a security company to integrate your internal employee directory with their security system. This way, your employees use their internal employee badge, their corporate identity. And when you deprovision employees in the corporate directory, it automatically takes care of their building access, since their access is determined by your internal corporate system. Stepping back from the analogy, the identity federation example represents setting up single sign-on to the AWS console using your internal corporate credentials. Users log in to a separate system, separate from the AWS console, using their corporate credentials, and they are presented with a page that shows the AWS accounts and roles they can assume. There are no IAM users in this situation. All authentication is via corporate credentials, usually Active Directory. You are given an access based on Active Directory group memberships, and those groups are mapped to AWS IAM roles. One of the key considerations when doing identity federation, especially at scale, is how to automate all this. We aren't really going to get into this topic in the webinar, but in order to truly take advantage of the scalability that can come with identity federation, you need to consider how to automate things like deployment of IAM roles and policies to all of your accounts in a centralized kind of CI/CD driven method, deployment of groups and memberships in your employee directory, things like that. All right, so here's the agenda. We just went over the evolution of identity management. I'm going to do a quick identity federation primer, and then we're going to jump into the demos. So in general, what are the benefits of identity federation? It helps you manage your access to AWS at scale, but you'll still need some automation. It aligns your corporate user provisioning and deprovisioning with AWS identity and access management. It centralizes entitlement management, and it makes access for your users a lot easier when they're going in and using the console and accessing AWS services. All right, so looking at the benefits in general, we have, from a user standpoint, before identity federation, you had unique credentials. After, you're looking at single sign-on. From security, you're moving from long-term access keys to temporary security credentials. And then for compliance, you're going from a one-off, per account setup to a system that's really aligned with your internal controls. And it really does make a difference, these three changes here. All right, we'll jump out of the slides in just a minute and do a demo. The first demo is going to be SAML federation using ADFS, the Active Directory Federation Service. So it's identity federation using SAML, and most of these identity federation solutions I see out there use SAML. SAML is an XML-based framework. It's used to communicate user authentication, entitlements, attribute information, things like that. All right. So if we look at kind of the general overall view here, there's really three objects. There's the principal, Alice, in this case, who needs access to the console and to API endpoints. Then there's the identity provider, which is the customer, and the service provider, which in this case is AWS. There are multiple accounts in this situation. We have the App1 prod account here. We'll also look at App1 dev and some other accounts. But as I look at these screens, imagine the setup exists in each AWS account. All right, so going a bit deeper into how this works, the identity provider is ADFS in this case. There is an authoritative identity source, that's your user directory where all your accounts and groups are, and that's usually Active Directory. And then we establish a trust between the identity provider, you the customer, and AWS, the service provider. And the way that's done is there's an exchange of metadata between the identity provider and the service provider. You transfer metadata from ADFS into IAM, and then in ADFS you configure it to connect to our endpoint for metadata. And this information allows us to securely then transfer information about the authentication of your users. So basically, when an identity wants access to a resource at the service provider, an object called a SAML assertion is sent from the identity provider to the service provider. This SAML assertion contains the user's identity, attributes, role information, authentication method, and other elements. The service provider, AWS, consumes this data in a trusted and reliable way using that trust that was established with that exchange of the metadata. And so that's kind of, on a high level, the basics of identity federation using SAML. Now, as far as the mechanics of how we actually map the things in Active Directory to the things in IAM, usually this is done by mapping a group to a role. There are other ways of doing this. You could map an individual user to a role, but you need to map some identity within Active Directory to a role in AWS. And one group in Active Directory can actually map to multiple roles. So you're not restricted to just one role. And so that's kind of the basic setup. And then imagine this replicated in every account that you need access to, so that users can access multiple accounts. So here is the final look of it. And this link, which will also be in the resources slide at the very end of the deck, talks about the setup I'm going to demo. So you could do this yourself if you wanted to try this out. All right, let's jump into the demo. All right, so first we're going to look at Active Directory. And in this case, we are talking about Alice again, and this is her user object in Active Directory. She is a member of one particular group, AWS-admin. And the way this works for this example, and again, there's many different ways of doing this. In ADFS, and we'll look at that in a second, there are claims that are created that help map attributes in Active Directory to the role information in AWS. And the mappings in this case are taking any groups that begin with AWS, removing the AWS, adding ADFS, so it would be ADFS-admin, and adding the additional information for the Amazon resource name so that a role can be constructed. And that is how the mapping occurs. And then to determine which accounts Alice can access, we use another attribute called URL, and you could use any attribute. And you're basically just adding the account ID for the account that Alice needs to access. And so you would basically add your users to the groups they need access to, add in their attribute the accounts they need access to. And what this does is it allows you to use one set of Active Directory groups that are mapped to the same names as roles in AWS in every single account. One alternative is using a separate Active Directory group for the role in each AWS account, which could result in a lot of Active Directory groups. This is a simpler way of doing it, but again, this is just one way of setting this up, not the only way. All right, popping into ADFS. So there is this object representing Amazon Web Services. This is called the relying party. and this sets up the relying party trust. Right here, you can see the URL that gets us the metadata from AWS. And then if we go in here and edit the claim rules, these are basically, like I said, ways of mapping your attributes in Active Directory to things that would be useful in AWS. Some of this is just things like getting your AD groups. There is that renaming I mentioned, renaming those groups from AWS Dash to ADFS. We also set the session duration. We recently launched the ability to do a 12-hour duration. And that is that setup. So let's look at how this looks from the actual login. So this is the ADFS login page. You can modify this however you want. A lot of options there. And I am logging in with Alice's Active Directory credentials. And I'm presented with this page. This is sent to me by AWS after I've sent AWS that assertion that showed the roles that I can access and the account IDs. You saw that she had 2 account IDs in her attribute, and she's only a member of one particular group. But I can click this, sign in, and now I'm in the console. Just to show you the setup from the AWS side, basically we have an identity provider. This is the identity provider for ADFS, and this is where the metadata from ADFS was uploaded. And then there is a role that trusts that identity provider. This is the role, and you can see the name here, ADFS-admin. And of course, there's additional information added to make the full ARN, but this is that mapping from that group you saw that was titled AWS-admin. And down here, you can see the trust entity. And that's the basic setup for that. All right, so now we are going to actually look at how to set this up directly. So let's say we have an account, app1-dev account, and we have not set this up yet for Identity Federation. Now, obviously, you would be automating what I'm about to do manually, but just to show you what the setup looks like, we'll just do it like this. So I log into the console. I need to do 2 things. I need to create the identity provider that we saw before. And so I'll choose SAML as the provider type. We'll call this ADFS. And I have to upload the metadata file. So this is the metadata file from ADFS that I downloaded from ADFS on that server. So I go ahead and upload that. Create. And that's it. That's all that's needed for establishing that trust, really. Then the trust itself is really manifested by creating a role. So we're going to create a role. The provider is that ADFS identity provider we just created. It does a default attribute in the conditions for the audience, basically saying that this can only be used for this SAML Federation login. And you can add other conditions to this. I'm going to make this with admin access, and we will title this ADFS-admin. Create the role. So now we have a role in this new account. The only thing I have to do at this point is configure Alice to be able to access that account. So I have to edit the attributes, add the account ID for that account. Now Alice has access to that account. I need to log out because I need to get a refreshed set of her attributes since we have added a new attribute for her. Log in. And you can see we have a new account here, this app1-dev account. I can log into this now. I'm in. I'm using a role for this. So the user that was here before, I can just go ahead and delete. And so now we have no users in this account. All we have to do is add users to the Active Directory group to give them access to this role we created. And then within their attribute, add the account ID so that they can get access to this particular account if they need access to it. And that's the basic setup for that. One thing I've been asked before is how easy it is to switch back and forth between roles. So I just wanted to show you how easy you can quickly go from one role to another if you're needing to switch accounts a lot. And then one other thing I wanted to show you is that this is all tracked using the username of Alice. So you can see this ADFS-admin is the role name, and then this Alice at awstest.local is the email address configured for Alice. So that's all available, and if you go into CloudTrail, you can see that that's properly being tracked. You can see here, console login for Alice. So you can attribute all actions for these federated identity users to whatever they do. One other thing here, this friendly name you see here, this actually comes from the IAM alias. You go into the IAM dashboard and you can set these friendly names up for ADFS. So that just makes it easier for your users. One last thing, you can also do this from the CLI to get temporary credentials. So there's a number of different solutions for doing this. We have a Python script that's been published in a couple of different blog posts. We have an official way of doing it through the CLI. All these links will be in that resources slide I mentioned. I use SAML to AWS. I'm in no way advocating this tool. It's just one tool that's out there. But you basically log in. It caches your password, probably not the best way to go, but it makes it easy for a demo. And it presents you with this page that looks very similar to the web page we saw before. Let me just put those side by side. You can see it's basically presenting me with the same choice the web interface did. I can choose our new account that I was given access to. And what this does is it grabs temporary credentials and it writes it into the credentials file. So it just wrote this, and then it writes it into a profile called SAML, but that's configurable. I could do a list using that. Of course, I don't have any buckets there. We'll log into an account that actually has buckets. You can see it's very easy to switch back and forth. We'll go into the prod account. Oops. And we can see there's one bucket in that account. So anyways, that makes it really easy to switch back and forth, both from the browser and from the command line. All right, moving on to the next demo. We're going to look at federation using a new product we have called AWS SSO. All right, so this is going to be fairly similar to what you saw before. There is, again, an identity provider represented by the customer and a service provider represented by AWS. Again, there is also an authoritative identity source, Active Directory, your corporate directory. And just to be clear, that could be anything. It could be an LDAP directory. It's just your corporate directory. In this case, though, the identity provider isn't sitting on your network. It's sitting in AWS, and it's SSO. There's still a trust relationship set up. There's still an exchange of metadata from IAM to SSO to establish that trust. Now, you also have to set up a directory service, AWS Directory Service or AD connector, and then that system will need a two-way trust if you're using directory service, a two-way trust to your on-premise Active Directory. The trust from AWS to the customer is required so we can do user and group lookups. But other than that, it's fairly similar as far as the mechanics of identity federation and SAML to the ADFS example. And then again, from the standpoint of the mappings, it's very similar. We are again mapping AD groups to IAM roles. The names are different and the setup of it is different, but it's essentially the same from that respect. Okay. Let's jump back into the demo. So I'm going to first show you the console. AWS SSO is tied in with organizations. So this listing of accounts actually came from organizations. And I could, if I wanted to, just look at individual trees within the organization. But this is all my accounts right here. So there's a couple things here. There's permissions sets, which are similar to roles. And the way that SSO kind of differentiates itself from, say, ADFS is the way it allows you to deploy the various roles to all the accounts. So what I can do here, let's say I needed to set up access for the security auditors for our company. And I want to do it in all the accounts. I can't do it into the master account. It restricts that because you really shouldn't be using the master account for anything, because that's where, you know, organization sits and SSO sits and needs to be properly secured. So anyways, I'm going to assign some users. This choice screen allows me to get the groups from Active Directory. So as I do this search, what it's doing is it's pulling up the Active Directory groups that you saw already in my Active Directory setup. So I'm going to choose the AWS Security Audit group. I need to create a new permission set. Here you can use, you know, manage policies. You can use these job function policies, or you can just do a custom permission set and write your own JSON file for that. But I'm going to use the job function policy for security audit. Select that as my permission set. Now what's happening is SSO is pushing to every AWS account in your organization. And you can do this within a tree or just choose one account or just a couple accounts. But in this case, I chose all of the accounts in my organization. It pushed, if it wasn't present, the identity federation object that we saw before that needed to be created that has the metadata. And it creates the role that needs to be created for this setup we're doing. It does that automatically for you. So I pushed that out. The only thing I need to do at this point to be able to get access for Alice is add Alice to that Active Directory group. So here's Alice. I'm going to add her to the group there. Now, when we go into the SSO console and log in, and so this is, you know, a very similar setup to what you saw with ADFS. The difference being that this lives in AWS as opposed to ADFS, which would live in your own network. I'm logging in with Alice's Active Directory credentials. And I'm presented with a screen very similar to what you saw with ADFS. Now, the difference here is that that role that I just pushed was automatically pushed to all these accounts. Now, if I wanted to log into one of these accounts with that security audit role, I just go to the management console, and then I'm in. So very similar in respects to the experience from the standpoint of the user, but from the standpoint of the administration, there is some differences there. As you saw, it's pretty easy to push those roles out. If I log in to the SSO admin account, into one of these accounts, just wanted to show you that, again, here, all this is trackable to the user. This long name here is the role that SSO created, and you can see within there, you do see SSO-admin. And at the very end, you see /Alice at AWS test.local. For SSO, that actually comes from the user principal name. So you have to configure that, and that's how you're able to track users within the console. And so if I log in to the CloudTrail console, I can see the console logins for Alice. I can see the username, and all the actions she take would be trackable via CloudTrail using her username. So there's no difference there from, you know, a standard IAM user and someone logging in with Identity Federation. I am also able to get temporary credentials. So if I do the command line login, it's a little different here than ADFS. I'm not doing this from the CLI. I have to go into the console. But from here, I can copy the credentials, and then I can paste these in to the credentials file. And these are temporary credentials that are good for an hour. And then you're able to make commands and things like that. Yeah, it's not quite as easy as with ADFS, but you can definitely copy this from the console. So your users can still do commands from the command line using temporary credentials. All right. That is kind of it for the demo of AWS SSO. Let's make sure I didn't miss anything here. One other thing here, this is where you configure it to connect to a AWS Active Directory. And then from that AWS Active Directory, you establish the trust relationships to, say, your on-premise Active Directory. You can establish to a forest, which has multiple domains. All those domains will be accessible, and even establish it to multiple domains if you want to have those accessible for those users. And you can also edit the attribute mappings here. All right. Let me pop back into the presentation. So next steps, a couple thoughts here. There are a lot of ways to do identity federation. ADFS itself is at no cost from Microsoft. AWS SSO is at no cost. So if you wanted to just kind of get started playing around with this, testing it out, it'd be easy to do that. If you already have your own identity provider, then I would definitely recommend looking at using that. We provide information on how to support identity federation with a number of third-party providers. I have the link here, Okta, Ping Identity, things like that. So definitely consider at least setting up a POC and testing this out. And you can set this up within the same account for multiple different identity providers. The accounts I showed you were both using SSO and ADFS. And also, please keep in mind that you need to lock down the root user. You really shouldn't be using it. It shouldn't have any access keys attached to it. And it should definitely have MFA attached to it. All right, so I think in the past, the impression was that identity federation was primarily a solution found in enterprises. One of the messages I would like to try to press is that identity federation is not just for enterprises anymore. Any company going through the evolution of identity and access management on AWS will benefit from moving to identity federation. There's a lot of benefits there, and I hope that you will take a look at it and at least do a POC and see if it's a solution that would work for you. All right, that is it for the presentation. We will now move on to some live questions.